So we are at chapter 12. So it's 12 out of 12. Sorry, imagine that. Chapter 12 is just a big addition to chapter 3. So I'm going to actually review chapter 3 since it might not be in the front of your mind right now. And the big idea in chapter 12 is we're going to see a linear association. So that's a line, a linear association between two variables again. So we're going to revisit that again. So let's, on the blank paper, that's where I want you to put some review notes from chapter 3 as I guide you through them. So on the blank paper, this is chapter 3 review. I'm only reviewing the principles that we're going to need for chapter 12. So let's start with a graph, a good old friend of ours from chapter 3, and that was body weights.
Man, I remember doing it. It's a weird thing for you guys
So, if you want to give yourself a graph, and just about 8 points, they don't have to really match mine, but have them sort of ascend in a sort of linear way. And make sure there's 8 of them. Just something like what I put on the board. And then pick a line of best fit that goes through them. It may touch them, it may not touch any of them, but it should be just as many above as below. And that was called the least squares regression line. So that is a review. And now see if you can remember what these are. Actually, this came up on our card review. So what were these called?
Oh, I should know.
What are they?
I don't. I said I should.
Oh, residuals.
Very good.
Yeah.
You heard that from me.
Residuals.
No, I didn't.
Residuals.
Did you say residuals?
Least
I didn't hear you.
squared regression line. I'm just going to abbreviate it. Least squares regression line. And residuals. And another friend we need to remember, which actually I had to look up, was S. And when I taught S, I said, we're going to talk about this later, and I'm going to forget it, so help me remember it. Can you? S. S was a quantity. It is not. So S sub X or SD or that symbol for standard deviation, but plain old S meant something different. It is the standard deviation of
The residuals.
right, the standard deviation, not of the graph, but not of those data points, but the standard deviation of the residuals. And let's put that in common everyday language. The standard deviation of the residuals means, and I'll write this up, but I just want to speak it to your face. The standard deviation of the residuals is the average amount that we will be off if we use this least squares regression line.
Right.
So that means the same thing.
This is making lots
The
of sense.
average, does that ring a bell, all of that? The average amount we will be off using L least squares regression line, LSRL. All right, so then we actually put the data in our calculator a long time ago, and we found a least squares regression line. And we called it y hat equals a plus bx. Now, x is the body weights. So I'm going to decorate this so you know what each of these is. This is the body weights. We also called that, there was a name we gave this variable and this variable. Does anyone recall?
What variable? What variable?
We actually gave these variables a name in general. One of them was,
It's like one was like the one that's caused and the one
yeah.
caused
Oh.
by, but I don't remember what it's called.
All right, I'll give you the 2 words and see if you can tell me which is
Signified
which
and
on this one.
signifier.
One is response, and the other is explanatory.
Explanatory.
Explanatory
Explanatory.
is
I don't. Wait. Oh, X explains. X is the explanatory. Yeah.
Alright, X
Wait.
is the X-axis.
X is it? No, you said body weights. Morgan, body weights is X, which is explanatory. Backpack weights is R.
Backpack weights.
Backpack weights.
Explanatory explains things about the response. And so I'll put that in for way of review as well. And we remembered it because the explanatory was on the X-axis, so some things do stick.
Only way I knew that.
All right, what does the hat mean on the, well, wait, how Y is the backpack weights? So what does the hat mean? You remember what the hat means in this scenario?
It's raining. It's sunny.
Nope,
Proportion.
nope,
So you should have
Summation.
expected amount, or we'll call it predicted. Predicted by the least squares regression line. So it means predicted.
Wait, what means predicted? The hat.
The hat is the Y that is predicted by the least squares regression line. And lastly, A and B. A is where it crosses, it's the Y-intercept. Sometimes it's meaningful, sometimes it's not meaningful. In this scenario, this crosses the Y-axis right there. In this scenario, is that meaningful? No. Why? Can you explain to me what is nonsensical about
It
it?
has nothing to do with the.
Yeah, so
like,
weighs
our
0 pounds doesn't
deviation.
matter because they.
Right, this says if someone weighs 0 pounds, their backpack weight is 2.1. That is nonsensical. Sometimes the Y-intercept is meaningful, sometimes is ludicrous. Alright, it's good, it's for a good joke sometimes. Alright,
Good
so,
Josh.
alright, so now this
Josh Brown.
is the slope. And let's see if we can get the actual least squares regression line out of our calculator. First, you have to put in these values. These are the body weights. These are the backpack weights that we observed on our sample. So go ahead now and go over to, if I can recall, StatCalc. Now, what's a StatCalc?
For what? The
We're looking for these numbers, A and B.
A plus B.
oh, it's Lin Reg, A, right? AX plus B.
Oh, 4. Number
It's
4.
like number, I don't
It's-
think it's
I-
4.
Oh, it's A plus BX, so it's 8.
8.
It's 8
Yeah,
because you
'Cause
have
it's-
to pair the B
Yeah.
with the X.
Yeah, so
All right,
got
so-
it.
so
X
what
list-
is it?
I got A as 16.
Wait.
0.26.
Okay, I'll say 3 then.
B as 0.09.
All right, 0.90.
mine told me to quit.
7.
Wait, what did you put in for frequency list?
I put L5.
R
It didn't ask
squared
for it.
is point.
If you need a frequency list, that's why I kind of give this dummy list. This just tells you how often, how frequent do they want to use each of these.
Yeah, it's
So,
that.
I just want to use it once.
Wait, so what frequency list did you put L5?
If they, yeah, frequency
didn't
list.
Okay, I think
Sometimes
that's.
we got away without that.
Mine keeps saying error. Check one dim list
Do you need R or squared?
less than
Shannon, did
999.
yours work?
Yeah, I didn't
I
get
have a
R.
question.
Yeah.
So,
You got the same numbers as her, but you didn't get
the L1 and L2, what do those represent?
Now one is the explanatory variables
Oh,
in
shoot,
the
okay.
sample.
So I need to put in-
These are the body weights in the sample we studied, and these are the backpack weights. The
Wait, so body weight is L1, right?
Yes.
Okay, then that's why I did it wrong. Okay, Morgan, did you get 16.2 for A?
Here it
Okay,
is.
cool.
All right, so here is the least squares regression line, which we can use now to predict any body weight that comes into our little
Anybody?
bodies.
Wait.
All right, so does that come back pretty good? That wasn't so bad, was it? All right, so yeah,
Heather and I are getting the right numbers.
okay. Did
Wait,
you
no,
put in the
you're
right
not getting the right
values?
numbers. I have.
But
Maggie,
you're not getting R squared.
Maggie, when mine came up, it said L3 and L4 for X list and Y list. You might have to change it to L1 and L2. That's what I had to
But I
do.
changed it to L1.
Wait, are you gonna hurry?
Go Haley and Joel.
Yeah. Let me see your list, let's see if you messed that up. 120, 104.
Oh, 180.
Yeah, try that. Just check the numbers again.
You write square.
What about you? Are your numbers good?
Yeah, but I don't have an R and R square.
I can show you how to add that, but we don't need it today.
Yeah, because mine have
So
it.
16 and, oh yeah, your numbers are correct. So, all right. Let us go now to this chapter. So kind of set that aside and just keep an eye on that. And we're going to upgrade. This whole chapter will deal with regression lines. So keep all this on the down low.
This is not Puffs Plus.
This is signature home.
Mrs.
Yeah,
How?
fine. Here they are.
Yeah, those are for us, Morgan.
Those are for us.
Those are for us. Those
the
tissues are
nods.
for our nose.
We don't deserve
We
puff
get
plus.
There, this will work.
We did not take inner party tissues.
True.
Victory tissue.
Victory tissues.
I'm going
That one has
to
a
speak
telescreen
theory
on it that you
for a
can
few
turn.
minutes till the bell rings and probably finish theory tomorrow. But the problem is that you may not catch what I'm saying.
Uh-oh.
That's okay. When it gets to running the confidence interval and the tests, I think you'll be all right. I'll try my best to get the theory across, but you're not dead in the water if you don't quite understand the theory.
This means
it
none of you
always
understand.
helps, though. All right. So when we have this regression line represents one sample. That was 8 people, and we got a whole regression line from that. It is not the regression line for the whole population. Because in the whole population, we're going to have a ton of people that weigh 120, and they're going to carry a whole bunch of different backpacks than 26. So this only reflects this one scenario. So it is not the whole population. So let me give you the true blue regression line.
This is
So
chapter 12,
here's
right?
the population regression line.
No, okay. I was gonna say what?
And it looks like this. So this is not from a sample like this was. This is the real one. If we really, really knew the slope and the y-intercept, and we really knew the regression line, it would look like this.
Where do you want us to write this?
This is on your new notes.
What
This
part?
is chapter 12.
What's that? What do you mean?
This, everything of that was just to hold on the side to kind of keep your eye on and kind of bring back to mind. Alright, so we have the mean of y equals alpha plus beta x. So you'll notice down here, we had y hat equals a plus bx. So what we're going to end up doing, to make a long story short, is we are going to estimate the parameter alpha, which stands for the true blue y-intercept. We're going to estimate it with our sample A, and we're going to estimate our true blue slope for the whole population beta with our sample B. Very similar to how we used to do, we used x bar to estimate what?
Mean.
Right, x bar helped us figure out the mean, and what did p hat help us estimate?
Proportion.
All right, so I'll just kind of put that in a little box on the side. So the parameters were, and these were, what were these called?
Oh, what was that? Oh, shoot.
So the parameter would be mu.
We had them in the
and
box.
x bar would be called what? What do I call this list? P.
Proportion? No.
No,
What
You
else
called us
do
a
we
treasure
have?
chest.
that was a different box, I
We
think.
have, now we're gonna
I think
take
yeah,
the
statistic,
parameter
that's it.
alpha.
Is it statistic?
Yeah.
Yes.
No, it's not.
Good job, Morgan.
So, what we're gonna do, and we're gonna make confidence intervals, and we're gonna do tests in order for us to get the true parameters for A and B. Alpha and beta. I should say for alpha and beta. So, in fact, this is really the only one this chapter deals with. The slope. So we're going to do inference from our samples to estimate the true slope, and we're not even going to worry with alpha. So that gives you an idea of where we are going. So we are going to do inference to find beta. We're going to use confidence intervals. We're going to develop confidence intervals, like 95% confidence intervals. And we're going to do tests. We're going to do hypotheses to figure out beta as well. We're going to teach you both, how to do both. So you're very well trained in confidence intervals and tests, so it shouldn't be too big of a jump. The rest of the day, we will work with figuring out the preconditions. So we've had RIN, and then we had RIL, and today is a new set of conditions.
Great.
Here are the preconditions. And they are a little different than what we're
Linda.
used to.
Liner.
Where did you get Linda?
I saw Lynn.
Liner, if we are dealing with lines, least squares, regression lines, so liner should make sense.
Oh.
Alright. Let me start down this until the bell rings.
So we
In
have
fact, I
we
might
have
just stop
Rin
there and give
We
you
can make
the-
this say.
we have Rin and L in there. E is the only new one.
Yeah, easy. We can
Oh.
say.
We also
Rin.
have. We also.
Wait, it might be different
The
things
L.
though.
We
Like,
have
Rin.
Rin,
Make it
Ril,
Rinnle.
Lin, Line,
Rinnle.
Ren,
I was about to
Rhyme,
say we can make it say Linner, but that's what it
Len.
says.
Liner.
So, because we're not in a place where we can do other homework, we're going to cut up the next set of cards and study all our cards. We'll start tomorrow. I'll give each of you a card to do. Sorry. Then you will. That will be our assignment.
do you want me to stop recording?
Alright, just let me wrap it up.
Okay.
Okay. So, Haley, Joel, we're going to end right there and pick up preconditions tomorrow. We know they're going to follow this acronym LINER. And the only homework we have is to take these cards, cut them up, study them along with cards from A, B, and C sheets, and be ready when class starts to answer the card that I show you. Alright, that's it for today. Over and out.
Can